Second chapter, structure of atom. First of all, from where does the word atom come? Atom word comes from this is the Greek word atomos. Atomos means indivisible, uncuttable. If you remember in the first chapter, I taught you about Dalton's model of an atom. And Dalton's model said that an atom is the smallest particle of matter which does not have any internal structure. It means it is indivisible, it is uncuttable. So from there, the term atom was picked by Dalton. Now, right now, the term atom was derived from the Greek word atomos, which means indivisible or uncuttable. Indivisible or uncuttable. According to Dalton's model, an atom is the smallest particle of matter, which is indivisible and has no internal structure. No internal structure. Our later experiments proved that an atom consists of charged and neutral particles, and it has an internal structure. So very first the experiment was, you can say you'll know about it, Rutherford's experiment, who said on the basis of gold foil experiment, he proved that atom has an internal structure. It consists of a nucleus and extranuclear region. And today we know that an atom consists of three main types of particles: electrons, protons, and neutrons. This is a lengthy chapter. We'll consider discovery of electrons, discovery of protons, and discovery of neutrons. Everything is in your syllabus. Write on the heading, discovery of electron. Discovery of electron. Please draw the diagram which I am drawing on the board. Very simple diagram. Now see, I'll explain a bit, then I'll dictate. See, this is a long, very hard glass tube, which is called cathode ray tube or cathode ray experiment tube. This tube, you can see this has a side tube, and the side tube is connected to a vacuum pump. Because this tube is first filled with a gas, and with the help of vacuum pump, this gas is taken out so that the pressure of gas inside the tube decreases. On two ends of this tube, there are metal electrodes. Negative is cathode, positive is anode. And these two metal electrodes are connected to a source of high voltage. When high voltage is applied, then some invisible particles are produced which travel from cathode towards anode. These are invisible particles, but they travel from cathode towards anode. Since they are invisible, how were they proved? I'll tell you. Now, since these particles are produced at cathode, that is why they are called cathode ray particles or cathode rays. Right? First, try this much. And this was the experiment carried out by Faraday. Faraday carried out electrical discharge through gases at a low pressure in a cathode ray discharge tube or cathode ray tube, which is a long hard glass tube with the two metal electrodes sealed at its ends. It has a side tube connected to a vacuum pump so that pressure of the gas in the tube can be reduced. Next paragraph. When a gas at low pressure is taken in the tube and high voltage is applied across two electrodes, current starts flowing in the form of a stream of invisible particles. These particles are produced at cathode. Cathode is negative electrode connected to the battery. Produced at cathode, and therefore rays are called cathode rays or particles are called cathode ray particles. Now, to produce this type of rays, how much should be the pressure? What should be the voltage applied? That will depend on the nature of the gas. It means for different gases, voltage required and pressure of the gas which is taken inside the tube, that will be different. Continue. Next paragraph. Pressure of the gas and voltage required to produce cathode rays depends on nature of the gas nature of the gas taken in the discharge tube. Taken in the discharge tube. Next topic. In fact, it's a subtopic of this cathode discovery of electrons. Write down properties of cathode rays. Properties of cathode rays. See, I dictated you that these are invisible particles which are produced at cathode. They travel towards anode, but they are invisible. How was that proved? That they are produced at cathode. You can see this anode is perforated. Perforated means anode has some holes in it. This surface of tube, please add in the diagram, this portion of the tube behind anode, this is coated with zinc sulfide. Zinc sulfide is a fluorescent material. It glows when some particles fall on it. So when cathode rays are produced, they pass through holes of anode and they strike zinc sulfide coating. And when they strike zinc sulfide coating, a glow is produced, which proves that they are produced at cathode and they travel towards anode. So write down first property. They travel from cathode towards anode. From cathode towards anode. To confirm this, holes are made in the anode and a portion of glass tube behind anode is coated with ZnS, zinc sulfide, which is a fluorescent material. Cathode rays pass through these holes, strike zinc sulfide coating and produce glow, which proves that cathode rays travel from cathode towards anode. Second property. Since they are invisible, their properties are studied by the glow produced by them on zinc sulfide coating. I know whether you have seen or not earlier, TV monitors and televisions, they used to be so thick. Now they are very slim TVs, and those thick TVs, etc., they used to have a cathode ray tube inside, and picture which is formed on the screen, that is due to these cathode rays only. So continue same point. A TV picture tube, television picture tube, is a cathode ray tube which is coated with a fluorescent material, coated with a fluorescent material. Number three, third property. See, in physics, how do you prove that light travels in straight line? Because if you keep any solid object in the path of rays, shadow is cast. So same experiment is applicable in this case also. Number three, they produce shadow of the solid object kept in their path, which proves that they travel in straight lines. They travel in straight lines. Number four rather. You might have seen, even you might have played with the sort of paper fan made up of paper when you were a kid, and used to keep it under the fan, or when wind is blowing, it starts rotating. Why does that light fan made up of paper starts rotating with air? Because air contains material particles. It contains particles of different gases, and when these gases particles strike this, it starts rotating. Similarly, if a very light wheel, we call it paddle wheel, if a very light wheel is placed in the path of these cathode rays, that wheel will start rotating. And this proves that cathode rays are made up of particles. So write down number four. They rotate a light paddle wheel, P-A-D-D-L-E. They rotate a light paddle wheel kept in their path, which proves that they are made up of material particles. Made up of material particles. Look here for the next point. Outside this tube, if we apply electric field, let us say this is negative pole, this is positive pole. If we apply electric field outside the cathode ray tube, these rays are found to be deflected towards a positive plate. Since they are deflected toward positive plate, what does this prove? It proves that metal particles which constitute cathode rays, they are made up of negatively charged particles. So write down next point, number 5. They are deflected towards positive plate in an external electric field, which proves that they are made up of negatively charged particles called electrons. Next point. Look here. Let us say this is a very thin metal foil which is kept in the path of cathode rays. These cathode rays will penetrate through it and go the other side. So write down next point. They penetrate, and more this metal foil will become hot. They penetrate and heat a thin metal foil. Next point is a very important point. Write down. They cause ionization of the gas. They cause ionization of the gas. Now, what is the meaning of ionization of the gas? Just it will take 1 or 2 minutes. You have to understand this. Ionization means formation of ions. In this tube, we take the gas which is made up of atoms or made up of molecules. Whether it is atoms or molecules, they are in the neutral form. So when these electrons, cathode ray particles, they strike particles of the gas taken in the tube, they will knock out one or more electrons from gaseous particles. I'll go a bit slow so that you can understand. When cathode ray particles strike particles of the gas in the discharge tube, they will knock out one or more electrons from gaseous particles. Now, when one or more electrons are removed from neutral gaseous particles, what will happen? It will leave behind positive ions, and that is nothing but ionization. So cathode rays strike gaseous particles, one or more electrons are knocked out. These knocked out electrons become a part of cathode rays only, and they travel with them only. And positive particles, what will happen to them? That will take away anode rays, which will be the next topic next time. So this is called ionization of the gas. So write on next point. They cause ionization of the gas through which they pass. Through which they pass. Last point. See, the nature of these rays, nature of these cathode ray particles or anode ray particles, which we'll talk about later, that is represented in terms of charge of the particle divided by mass of the particle. This is represented as E by M ratio. E is charge of the particle, M is mass of the particle. Now, we take any gas in the discharge tube, we take any metal to form these electrodes, E by M ratio of cathode ray particles will remain constant. It does not change. What does it prove? It proves that all matter contains electrons, and the nature of electrons in every metal is same. It's not that electrons of oxygen and nitrogen are different. Electrons present in every matter are same, which is proved by E by M ratio. E by M ratio will remain constant. So this proves that electrons are the fundamental particle of all matter. When we say fundamental particle of all matter, it means electrons are present in every matter. Number two, electrons present in every matter have the same nature. So write down the last point. Nature of cathode ray particles. Nature of cathode ray particles, that is their E by M ratio. Their E by M ratio, if you want within brackets, you can write charge oblique mass ratio. Their E by M ratio is independent of the gas taken in the discharge tube and metal of electrodes used. This proves that electrons are the fundamental particle of all matter. Of all matter. Now, next topic, subtopic of the same topic rather, origin of cathode rays. Origin of cathode rays. This will be just one or two small sentences. I have already explained during this experiment. Initially, cathode rays are produced at cathode. but later cathode rays are also produced by ionization of the gas, because during ionization of gas, one or more electrons from gaseous particles are knocked out, and those knocked out electrons also become a part of cathode rays. They travel along with cathode rays coming from cathode. So write down, cathode rays are nothing but electrons. Cathode rays are nothing but electrons which first originate at cathode. Full stop. While moving towards anode, they cause ionization of the gas and produce more electrons. That is, more cathode rays. Next topic. Charge to mass ratio, E/m ratio of electron. Now, for this, I'll explain something. Try to understand. See, charge to mass ratio of any particle, not only electron, charge to mass ratio of any particle was calculated by Thomson, J.J. Thomson. What he did, let us see. Look here. Let us say this is the cathode ray tube, right? Cathode ray tube. Cathode is here, anode is this side. Electrons are produced, that is, electron means cathode rays are produced and they're traveling in this direction, right? Can you see this? Positive, wait a minute. Positive, negative means positive and negative plates of electrical field. South-north means south-north poles of a magnet, right? Let us say this cathode ray tube, is inserted in this hole. It means these cathode rays and these two fields, electric and magnetic fields, these two fields are perpendicular to each other, and they will also be perpendicular to the cathode rays in which they are moving. Now listen. In case only electric field is applied, I told you earlier also, cathode rays will be deflected towards positive plate. Number two, if only magnetic field is applied, then cathode rays are deflected towards north pole. If no field is applied, cathode rays, I told you in one of the properties, they travel in straight line. I'll repeat quickly. No field applied, they travel in straight line. When only electric field is applied, they're deflected towards positive plate. When only magnetic field is applied, then they're deflected towards north pole. Now, if electric and magnetic fields are applied together simultaneously, and their field strength is adjusted, means increased or decreased. By adjusting their field strengths, these cathode rays can be made to travel in a straight line again. I'll repeat, when electric and magnetic fields both are applied, their field strengths are adjusted. Cathode ray particles can be made to move in a straight line as they do in the absence of any field. On the basis of this, how much is the electric field strength or magnetic field strength applied. Thomson carried out some calculations and calculated the value of E by M ratio of cathode rays, that is electrons. Right? Now write on. We should be able to finish this write-up. Thomson measured E by M ratio of electrons by simultaneously applying electric and magnetic fields perpendicular to each other and also perpendicular to the path of cathode rays. Next paragraph. When no field is applied, cathode rays travel in straight lines. Full stop. When only electric field is applied, they are deflected towards positive plate. Again, full stop. When only magnetic field is applied, they are slightly deflected towards north pole. However, when both the fields are applied together and their field strength is adjusted, cathode rays can be made to travel in straight line as they do in the absence of any external field. Now, as I said, when we apply only one of the two fields, there will be deflection. And how much is the deflection? What is the angle of deflection? That will depend on three factors. Very simple factors. Right on next paragraph. Angle of deviation of any charged particle, maybe positive or negative, any angle of deviation of any charged particle from its path in the presence of electric and magnetic field depends on number one, charge on the particle, within brackets write down directly proportional. It means more the charge on the particle, more will be the angle of deviation. Number two, mass of the particle, weight of the particle, within brackets inversely proportional. It means if the particle is heavy, angle of deviation will be less. And last, third factor, strength of the applied field. Strength of the applied field, within brackets, directly proportional. So more the strength of electric or magnetic field, more will be the angle of deviation of a charged particle. Next paragraph. By measuring applied field strengths and angle of deviation, Thomson calculated E/m ratio of electrons, which was found to be 1.7588 into 10⁻11 coulomb per kg. I'll repeat, always written on the board, was found to be 1.7588 into 10⁻11 coulomb per kg. This value is constant irrespective of.
So could you repeat what you said just right now?
This value is constant irrespective of gas taken in the tube and metal of the electrodes used. Now, I'll try to take up a small topic. If possible, I'll complete. Otherwise, at least I'll explain today. Right, our next topic. Charge on the electron. Charge on the electron. See, there was a scientist called Millikan, R.A. Millikan. He developed a method called oil drop method. You need not go for the details of this method. On the basis of that experiment, he calculated the charge on any particle. So charge on the particle was calculated by R.A. Millikan, and he found that the charge on an electron is 1.6022 into 10⁻19 coulomb. Now we know the value of E/m. We know the value of charge, that is E. Now if we divide this charge by the value of E/m, we get the value of mass of the electron. Right? So it's a very simple topic, small topic. Right on. R.A. Millikan, R.A. Milliken. R.A. Millikan developed a method called oil drop method. To determine the charge on any particle. He found that the charge of an electron is 1.6022 into 10⁻19 coulomb. I'll repeat, 1.6022 into 10⁻19 coulomb of negative charge. Nature of the charge is negative charge, which is called 1 unit of negative charge. So what is 1 unit of negative charge? charge on an electron is called 1 unit of negative charge, and its precise value is 1.6022 into 10 to the power minus 19 coulomb. Now, rest you copy from the board. Thus, mass of electron will be charge divided by E by M ratio. Value of charge is 1.6022 into 10 to the power minus 19 coulomb. Value of E by M, I told you earlier, this is 1.7588 into 10 to the power 11 coulomb per kg. On dividing, we get 9.1094 into 10 to the power minus 31 kg. So the mass of electron is 9.1094 into 10 to the power minus 31 kg. Charge of the electron is 1.6022 into 10 to the power minus 19 coulomb. Now, next paragraph. We will not be using such precise values in calculations when you attempt any numerical. Right on. Value of charge and mass, value of charge and mass of electron is rounded off to 1.6 into 10 to the power minus 19 coulomb and 9.1 into 10 to the power minus 31 kilogram respectively. Kilogram respectively. Now, on the basis of this, we'll solve one numerical. It will take just 2 minutes. I'm sharing on WhatsApp. Check your WhatsApp message, you'll find it. Question, numerical is calculate the number and mass of electrons which carry a total of so much of charge. Now, if we divide the total charge by the charge of one electron, we get number of electrons. So, number of electrons will be total charge, that is 8 into 10 to the power minus 19 coulomb divided by charge of one electron, sorry, minus 10 divided by 1.6 into 10 to the power minus 19. So this will be 5 into 10 to the power minus 9 electrons. This is one answer, number of electrons. Second, we have to calculate the mass of these electrons. We know the mass of one electron and we know number of electrons, multiply, will get mass of electrons. So mass of electrons will be number of electrons multiplied by mass of one electron, 9.1 into 10 to the power minus 31 kg. This will be the second answer, 4.55 into 10 to the power minus 21 kg. Right? So this is the second answer. So as we decided, for 2 to 3 weeks, we'll have one class per week. In case